Module 5 continues. Next topic, steel frame. So steel frame means the frame building may be made up of steel. Mainly there are different types of steels available like tool steel, HYSD bars, mild steel, etc. So out of that type of steels, mild steel bars are preferred than other steel sections, mainly because it has more flexibility, more plasticity or ductility, and it does not suddenly crack like glass, but it slowly bends out of shape. So, thus giving warning to inhabitants to escape from the building before failure. And steel in most cases performs far better in earthquakes. The disadvantage of using steel is that it loses its strength in fire. Or more precisely, we can say that at 500 degrees Celsius, mild steel can lose almost half of its strength. So, in order to protect the mild steel from fire or high temperature, we can wrap it with boots or spray on material called fire protection. Next, usage of steel frame structures. So steel frame structures are mainly used in making high-rise buildings, industrial buildings and warehouse buildings, residential buildings and temporary structures. So in high-rise buildings, we are using steel frame structures mainly because of its high strength, low weight and speed of construction. In industrial buildings and warehouse buildings, we prefer steel sections mainly because it creates large span spaces at very low cost. Next, in residential buildings, we use this technique mainly because of the usage of light gauge steel constructions. Next, in temporary structures, we can easily move the steel structures from one place to another. Next, types of building constructions. So, steel construction is also called as steel fabrication. So, first one, conventional steel fabrication. This is adopted when teams of steel fabricators cut the steel into correct lengths, weld them, and they will make the final structures. They can be done either in site or in workshop. In site, it is labor intensive, but in workshop, better working conditions is created and more precise will be the structures. Next, bolted steel construction. So mainly the steel fabricators or steel constructors mainly prefer the bolted steel connections or construction, mainly because it produces finished and painted steel components which can be shipped to the site and simply bolted at the place. So mainly the work is mainly done at the site by lifting the steel members into the place by using cranes and then bolting. The work site is tremendously fast. So that is the main advantage of using the bolted connection. You can see the two pictures of the bolted connections. You can see the bolts here. There will be connections by using cleat angles, etc., which we will be studying in your 7th semester. Next, light gauge steel constructions. These are mainly used for residential and small buildings. Mainly it consists of very thin sheets of 1 to 3 mm size, which can be made into different sections, sizes, shapes, C sections or Z sections. Next comes features of structural steel construction. So what are the construction aspects of using the steel construction? So first one is it is quicker to erect and can be prepared at off-site. Off-site means it can be prepared from factory or workshop, which has greater quality control. Next, second one, erection in site is affected by climatic conditions. but when compared to the reinforced concrete structures, it is least effective. Then second point, longer and highly coordinated planning. That is, time to time structural design can be made, fabrication can be done, and it can be delivered also. Third point, higher requirement in control of dimensional accuracy. That is, the fabricators can control the accuracy of the work because most of the works are prefabricated. Next, demand greater transportation or craneage provisions. Since most of the steelworks are prefabricated, they require greater transportation charges. Then next point, complicated quality assurance procedures, especially in the control of welding connection. And more complex, the steel structures will be more complex when dealing with gigantic and taller buildings. So it may be tiresome to use those structures. Next, induce more works at higher altitude. Next comes the structural characteristics of steel frame structures. When compared to the concrete, steel has lower dead load. Steel frame can easily uh, can be used for new design than that of concrete because the layout can be changed easily and especially requiring alteration after completion of the work. We can just take out the bolts and reconnect those connections. So it is far better or simple than that of the concrete constructions. Then beams usually are shallower in size than that of the concrete beams. Next point, sections in various convenient type and size can be made, hence economical in design, refer to standard steel sections. Next, easily accommodate building movements for steel as it is highly flexible to take up the strain and deformation. So it can strain and deform without failure. So it is far more flexible than that of the concrete structures. Next, but one disadvantage is that it is weaker in fire resistance and it will into highly deform and it can produce serious issues at higher temperature, normally about 500 degrees Celsius or above. And next point is that it can produce larger deflection and deformation in the case of wind, and it may cause uncomfort to users of building. Next, the steel has higher thermal expansion values, and the last disadvantage is that it has rusting or corrosion problems. Hence, anti-corrosion treatment has to be applied to these structures before erecting those structures. Next, how we can erect steel structures. Erection of steel structures is the process by which fabricated structural members are assembled to form a skeleton of this steel structure. So it can consist of four main tasks. First one, we have to establish any structure before construction. What we have to do, we have to establish the foundation for making safe erection. Then lifting and placing these components into position by using cranes. And if needed, we can provide bracings, etc. Then next one is aligning the structure by checking the column bases, then lining those structures, then making the columns erect. Then finally, we have to bolt up or weld up those sections. The erection process requires considerable planning before erecting, and we have to plan the materials delivery in order to minimize the storage requirement. The erection of structural steel work can be made safe and accurate if temporary support, false work, staging, etc. are erected, as in the case of concrete structures. Before erection, we have to verify all the plans, markings, shipping list, etc. at the site. The structure components received for erection should be stacked in such a way that it is not the erection sequence is not affected due to improper storing. So care should be taken that these stored steels does not come in contact with earth or accumulated water. Then stacking of the structure should be done in such a way that erection marks and mark numbers on components are visible and the handling is not becoming difficult. Safe transportation of fabricated items to the site, proper storage is a very important factor during the erection of steelwork. Next, the erection drawing should reach the site well in advance before the erection process or material handling takes place. Erection should be carried out with the help of maximum possible mechanization by using cranes. Normally, any one or more of the material handling systems such as tower crane can be used. The tower crane mainly consists of crane mounted on the rails, crawling cranes, pneumatic tire mounted cranes, and derrick crane may be used for handling the material. Normally, the selection of the method of erection is influenced by the type of the structures, site conditions, equipment, quality of skilled labor, etc. available to the erector. So these all are the points to be noted by erecting the steel structures.